All right, last page of the review. Number 17, what x values are solutions to the equation? So what you want to do on this one is use your graphing calculator. You're going to take this left side and type that into your y1 equals for graphing, and then you're going to take the right side and type that into y2 equals. You're going to graph both of these polynomials, and the x value solution is going to be figure out where the intersection point or points are. There might be more than one solution, and the x value of that intersection is going to be the solution. So type those into your graphing calculators. Verify that you're able to get x is about equal to 2.7. That is the point of intersection of those two lines. But it's actually, just make sure you're paying attention, it's the x value of the point of intersection. All right, number 18. What are all the real and complex roots of this function right here? Okay, so we could graph this, right? When you graph this on your graphing calculator, you will get real solutions. You'll be able to figure out what the x-intercepts are. Those are giving you real roots, real solutions of the function. That does not give you the complex solutions, and we have to make sure that we can find the complex solutions as well. So I would start by finding the real solutions. If you graph that, you're going to see that you have two of them. X equals -1 and +5. That's where this function crosses the x-axis. Okay, now we need the rest of the solutions. There should be 4 total between reals and complex, so we need 2 more complex. So what we're going to do is we're going to take our polynomial and we're going to divide it down. We're going to find other factors. So if x equals -1, that means that, x plus 1 was a factor, right? That it worked out evenly. So let's take our polynomial and divide it by x plus 1 to get the other factor. So if we do synthetic, we are going to put a -1 tricky x from the factor, right, into the box or into the corner. Check our polynomial. Are we missing any terms? We are not, so we can list off our coefficients. We have a 1, -4, 4, -36, and -45. All right, so let's run through that synthetic. Carry your first term down. Now multiply to the corner, you get a -1. Add down, you get -5. Multiply to the corner, you get 5. Add down, you get 9. Multiply the corner, you get -9. Add down, you get -45. Multiply to the corner, you get +45. Add down, and you get 0. So we knew that this would have a 0 remainder because this factor works out. It's one of the zeros of the function. So we knew that if we divided our polynomial by the factor x plus 1, we would get a 0 remainder that it would divide evenly. So let's fill in our x's. We have our constant term of -45. X to the first goes with the 9. X squared goes with the -5. And x to the third power goes with the x, or the 1. All right, so what we just figured out, we took our polynomial and we divided by one of the factors, x plus 1. We got back another polynomial, x cubed minus 5x squared plus 9x minus 45. Now to find the zeros of the function, we set them equal to 0. Well, x plus 1 equals 0, right? We already knew that was where we got our -1, 0. We already got that one. So when this one is set equal to 0, let's try to factor this. It's 4 terms. We can do our factor by grouping. If you group the first two terms, take out a GCF of x squared, leaves you with x minus 5. I'm going to carry down my plus sign. Let's take out a GCF here. 9 fits into both of those, leaves you with x minus 5. Notice that our parentheses are the same, so x minus 5 goes in one set and x squared plus 9 goes in the other set. So now that we factored those four terms, we can set these equal to 0 to get the rest of our the rest of the roots of the function. So when you set x minus 5 equal to 0, we get x equals positive 5, which we already knew. Remember, they gave us these two roots of the function, so we're just confirming that with our work. But here's how we're going to get the complex roots. There we go. I'm trying to move this. There we go. So if you take this other x squared plus 9 and set it equal to 0 and start solving, we would subtract 9 from both sides. So x squared equals negative 9. To undo the square operation, we're going to square root. When you square root both sides of an equation, we bring in our plus or minus. And then, can you square root a negative 9? No, you cannot. So we bring in I. Now we've got a positive 9. And then, now that it's positive, we actually can square root of 9. So plus or minus square root of 9 is 3i. So those are the other two roots that we're missing, or that we're asked to find. We've got two real roots and two complex roots. Let me go back to where the question was. Oh, well, I'll get rid of that in a second. Oh, I forgot. We got these two roots from our graph. So we got the negative 1 and 5 from the graph. Now we're adding to our list. We have a positive 3i and a negative 3i. We have found all of the roots, the real and the complex roots of this function. All right, number 19. A storage unit in the shape of a rectangular prism measures 2x feet long, x plus 8 feet wide, and x plus 9 feet tall. What are the dimensions of the storage unit in feet if its volume is 792? Okay, so we are being asked to find the dimensions. Right now, we know that the length is equal to 2x. The width is x plus 8. And the height is x plus 9. So if we can figure out the value of x, then we can just plug it into all three of those dimensions and get the length, width, and height. So because they gave us volume, let's set up a volume formula. Volume equals length, 2x times width, x plus 8 times height, x plus 9. We're going to set that equal to 792. And then we can have an equation where we are solving for x. All right, so to solve for x, we're going to want to multiply all this out. We're going to want to get that 792 over to the other side. But let's start by multiplying the right side. So we have 792 equals, we'll distribute the 2x. That gives us 2x squared plus 16x. Carry down your x plus 9, and now we're going to multiply that out. That's going to be 792 equals 2x squared times x is 2x cubed. 2x squared times 9 is positive 18x. 16x squared, excuse me. 16x times x is a positive 16x squared. And then 16x times 9 is a positive whatever 16 times 9 is, which is 144x. All right, I'm going to subtract 792 from both sides, and I'm going to combine like terms as I rewrite what we have going on. So this is going to give us, let's see, I'm going to change colors, there we go. 0 equals, we have our 2x cubed. I'm going to combine 18x squared and 16x squared. 18 plus 16 is 34x squared. We've got our 144, so plus 144x minus 792. Okay, so to solve for x, we could think about factoring. When you have four terms, you could try your factor by grouping. And thinking ahead a little bit, I'm able to see a couple steps down the line that factor by grouping won't work. Your parentheses are not going to match. So um, you could type this into your graphing calculator and see what the zeros of the function are. So the x-intercepts are the values of x that we're looking for. It is an x to the third power, so you could have up to 3 real roots. You could have 2 real roots or 1 real root. So if you guys graph this, you're going to find that it crosses the x-axis in just one spot at a positive 3. So the other 2 roots would be complex since they're not crossing the x-axis anywhere else. So now that we know the value of x, we basically used our graphing calculator to solve, found where it crosses the x-axis, so x equals 3. Let's go back to our length is 2 times x, so 2 times 3 gives us a length of 6. Our width is x plus 8, so 3 plus 8 is 11. We're just plugging in the 3. And 3 plus 9 for the height gives us 12. That's what they wanted, were the dimensions. All right, number 20, describe the behavior of the graph at each zero of f of x. So it's in factored form. We're able to identify the zeros, set each factor equal to 0. We have a 0 at x equals positive 2, and we have a 0 at x equals negative 1. Now, they did not ask us to describe the end behavior. They want the behavior of the graph at each zero. So what's happening at x equals 2? And what's happening at x equals negative 1. So you're either going to cross the x-axis at this point, or you're going to touch the x-axis at this point. It depends on the multiplicity of your factor. So I'm going to get rid of some of this up here so I have some space. The multiplicity is going to be the exponent with each factor right here. If there's not an exponent, you can go ahead and write in a 1. Well, that wasn't a very good one. Maybe I should write in the 1 first, and then there's my arrow. Okay, so if your multiplicity, if the exponent with your factor in factored form, if it's even, this polynomial is going to touch the x-axis at that factor. If it is odd, your polynomial is going to cross through the x-axis at that factor. So here at x, the factor is x minus 2, which gave us this 0 of x equals 2. It has a multiplicity of 2, which is even. The even multiplicity tells us that we are going to touch the x-axis at x equals 2. That would be a turning point if we were to graph this. Now, the 0 that we got from this factor, x plus 1, is x equals negative 1. It has an odd multiplicity. Odd multiplicities will cross the x-axis at x equals negative 1. So that's what describing the behavior means. Are you going to touch the x-axis or cross the x-axis at these zeros? All right, number 21. The student says the graph of f of x equals 0.5 x to the fourth plus 1 is a vertical stretch and a translation up 1 unit of the parent function. Explain the student's error. All right, well, first let's talk about this translation up 1 unit. That's this plus 1 on the end. So I think we feel good about that. Nice job. You got the vertical translation. Let's talk about this vertical stretch. So they are getting a vertical stretch from this 0.5. That's what made them say that. We're multiplying out front by a 0.5, so it must be a vertical stretch. Well, if this number out front is greater than 1, then it would be a vertical stretch. If it's between 0 and 1, so 0.5 is between 0 and 1, it actually is going to be a vertical compression. Vertical compressions would widen the graph. Vertical stretches will narrow the graph just so we have a visual of what's happening, but that number would have to be greater than 1 for it to be a stretch. All right, number 22. How does the graph of f of x equals 2 times x plus 1 cubed minus 3 compare to the graph of the parent function? All right, well, let's go through all the parts here. We have a 2 out front. That's a stretch or compression because that number is greater than 1. That is a vertical stretch. And then by a factor of 2. This plus 1 right here, tricky x, this is going to shift your graph to the left 1 unit. And then this minus 3 on the end is that vertical shift. It's very straightforward. It's a minus 3. We're going to go down 3 units. All right, last question. The volume of a refrigerator in cubic centimeters is given by the function right here. Write a new function for the volume of the refrigerator in standard form. So here's our function in factored form. We want standard form, so that just means we'll multiply this out. Standard form is just everything multiplied out. So let's start by distributing the x. We're going to have x squared plus x. Let's carry down the next factor from factored form, x minus 2. We'll go ahead and multiply this out. X squared times x is x to the third power. X squared times negative 2 is a negative 2x squared. X times x is a positive x squared. And x times a negative 2 is a negative 2x. Combining like terms, we have x cubed. Negative 2x squared plus x squared is a negative 1x squared. And then we've got our minus 2x on the end. This was a formula for volume, so v of x equals, and now we have our volume in standard form.